so here is my OneNote, and I went ahead and I started going over these questions. All right, so the first question here was, describe how C. parvum obtains the glucose it needs for glycolysis after it has infected another cell. Explain the role of lactate dehydrogenase in enabling the C. parvum to continue producing ATP by glycolysis. All right, so this parvum, all right, the C. parvum, and I'm skipping a little. I do suggest that you read the entire question and not go straight to the question because in the long run, there's always something that you need. So it tells you it's a parasite that infects human cells in the digestive system and causes illness. So this is, how is this going to get glucose it needs for glycolysis after it's infected another cell? So, it's living in the digestive system. So in short, it's going to absorb the glucose. I'm over here at A. It's going to absorb the glucose from its environment. All right, so it's a parasite, so it's going to be taking it from its host. All right, the next part of the question, explain the role of lactate dehydrogenase in enabling C. parvum to continue producing ATP by glycolysis. All right, so you have to know your glycolysis. So how does this continue? All right, so this lactate dehydrogenase, this is going to allow the NADH to be recycled to NAD, which you're seeing here. I have it underlined. So the glycolysis can continue to make ATP. All right, so you have to know what goes on in fermentation. And so you guys will have your notes with you and everything. Just make sure that you're organized. So if you had to glance back, remember when I went over this, I said it's really important that these electron carriers get recycled so that processes can be continued. We spent more time on cell rest. Don't forget about your fermentation. So a good thing to do is to go over your lactic acid fermentation as well as your alcohol fermentation, just so you have the general understanding of them and how those processes work. All right, so that would be 2 points. B, identify the independent variable used in the experiment. Identify the difference between the control cells and the experimental cells used in the experiment. Justify the researchers using a different range of concentration for FX11 than was used for gossypol. All right, so independent variable over here on B. The independent variable is going to be that chemical concentration. All right, either the gossypol or the FX11. Identify the difference between the control cells and the experimental cells using the experiment. I put the characteristics of the control cells would be the same cells infected with the C. parvum, but without the chemical treatment. So having the chemical treatment would be the experimental ones. So that is the difference. And then justify the researchers using a different range of concentrations for FX11 than was used for gossypol. Well, when you look at the concentrations of gossypol and FX11, you can see that the maximum concentration over here in figure 2 is 80, where it's 40 here. And really 80, I would say, like 80, they went up that far, but nothing's happening, right? From about, I don't know, 50 on, I'd say, almost 60 on, right? And over here, nothing's really happening from 30 on. So what's the difference? If you look at FX11, like where this curve right here starts to bend, and if I went down, that's about 30. Okay, that's starting to prevent the growth there. Where already at, I would say, I'm sorry, I was drawing the wrong line. Right around, about right there, anywhere between 10 and 15 is it's impacting it there. I would say at 10. All right, so let's see what I chose to write. FX11 did not impact the growth of C. parvum until it reached less than 30 micromoles, which was the maximum concentration of the gossypol. This shows that FX11 is effective at a lower concentration. So it might give the researchers some information. All right, so I wrote down 3 points for this one. Let's go on to letter C. Based on the data in figure 1, identify the concentration of gossypol that reduced C. parvum growth to 50% of that in control cells. All right, so let's go back to figure 1. This is an identify. You just got to write one thing. Gossypol, figure 1 is what we're looking at, and 50%. So if it was 100%, I want to look at where it's 50, and you want to go over, and then you want to come down, and that's going to be 15. And this looks like I have a typo here. I wrote 1.5. That's not good. So I want to change this. I wrote it here. I'm just giving you a tip. This is an identify question. And this identify question, you want to, if you don't have time, this is one. If you don't want to write the whole sentence, you will still get points for writing, 15 micromoles. Sorry, I'm writing with my laptop open. All right, one more to go. D, a researcher discovered a strain of C. parvum that expresses a functional variation of the lactate dehydrogenase gene. A DNA sequence comparison showed that the variant differs from the normal sequence in the region that codes for the enzyme's allosteric site. Predict the effect of the FX11 treatment on C. parvum cells that express this variant of lactase dehydrogenase. All right, so if these cells, if they express the variant, FX11 is not going to work because it's a non-competitive inhibitor. So now, this variant affects the shape, and so it affects the allosteric site, so it's not going to be able to bind. So I wrote over here, C. parvum's cells that express a variant of lactase dehydrogenase will not be affected by FX11. It says that's my prediction. Provide reasoning is what I need to do next. I put an allosteric site is where a non-competitive inhibitor binds, such as FX11. A non-competitive inhibitor such as FX11 would bind. Changing the DNA sequence would likely change the shape and prevent FX11 from binding. All right. There's my explanation, or my reasoning, excuse me. And then explain how gossypol and FX11 might be used as drugs to treat C. parvum infections in humans without negatively affecting human cells. All right, so this is a tricky one. I think you might get caught up and get stumped on this, or maybe you won't. Okay, if you read the whole question, it does give you background up here, although the eukaryote C. parvum does not have functional mitochondria and generates ATP only through glycolysis. All right, so they're asking about it being in human cells. So it's using the enzyme to perform fermentation after glycolysis. So when we go back, it's asking about without harming human cells. So I put humans have mitochondria and do not rely on fermentation to make ATP, so they won't be harmed. All right, so I would say this is another 3 points, and this is 1. So I'm going to guess that this is 3, 4, 7. This is only a 9 question. All right, so those are my answers, you guys. And if you scroll through this, you're going to see what the actual answers are in the rubric. And so you will be able to do that. And then the next question was this one, which we basically have already gone through. So I am going to just slowly scroll through this so that you can see what your answers are, because I have already gone over this one in the beginning or during last week. And so what I will show you here is a rubric for each of those. That was 3 points. Here's the same rubric. And that's it. I guess I'll sit right there for a little bit. Okay, you guys, I hope that's helpful. I will post this and make sure you go over your answers. The first question, they said it's a perfect match for something you could experience. It was also an enzyme question, and it was also an experimental one with variables, so I wanted you to be exposed to that. Remember to be as thorough as possible. You don't have to be concise, but you have to be thorough. Concise is best, but just get the right answers. You won't get them all, but the more we practice, the better you'll be off. All right, have a good day, everybody.